In this video, we will learn what an algorithm is and what makes a good algorithm. Assume you want to write a program that calculates the hourly pay of a user based on their input of the number of hours worked and their gross pay. A possible pseudocode for the process to solve this problem is as follows. Display how many hours did you work, input hours, display how much do you get paid, input gross pay, store the value of gross pay divided by hours in the rate variable, display the value in the rate variable. This process that you see right here is an algorithm. In simple terms, an algorithm is a series of operations to solve a problem. However, what makes a good algorithm? We know that this algorithm that we have right here is not good. Why? Because it doesn't consider the scenario where the user enters 0 worked hours. If we enter 0 hours, the algorithm will result in a runtime error because we try to divide by 0. A better algorithm would be the one that checks whether the number of hours entered by the user is 0. If it's non-zero, then we are good to go, and we can proceed by asking the user for the gross pay. If it's 0, however, we should take action. For example, we could print an error message and exit. Better yet, we could prompt the user for another input after printing a warning message that says the number of hours can be 0. This would be a better algorithm. Then how can we describe a good algorithm? One of the definitions of a good algorithm is a well-ordered collection of unambiguous and effectively computable operations. When executed, it produces a correct result and halts in a finite amount of time. Let's go over the definition and explain each part. First, a good algorithm is well-ordered, meaning the steps are in a clear and meaningful order. In our example, we can divide before we prompt the user for the gross pay. The collection of the steps also needs to be unambiguous. This means that the computing agent must understand the steps described. In our example, I could either say check for 0 numbers, which would mean either the gross pay or the hours, or both. A less ambiguous instruction would be check for 0 hours. The algorithm should also be computable. That means that we have what it takes to perform the computation. For example, the algorithm doesn't require a significant amount of memory or computational power beyond our computer's capacity. In our example, the algorithm needs to store the gross pay, the hours worked, and the hourly pay. It also needs a processor that can execute the algorithm to perform the division operation. The algorithm with these specifications should also give the correct results when executed in a reasonable finite time. For example, our algorithm is straightforward and should be computed in fractions of milliseconds. In contrast, an algorithm developed to align genome sequences could reasonably take hours to execute. You wouldn't, however, wait for an hour to get the result of dividing the gross pay by the number of hours worked, right?